Database Connection Part 2. This is Lecture 16 of Section 4. Let's begin. In this lecture, we will learn in detail about the for each and rows functions. We will learn about select queries and conditions, Groovy row result class, how to tell how many rows a SQL query returned, SQL query result as a list, update and insert SQL queries, parameterized execute and execute update, execute and execute update with map, changing a database dataset, followed by a quiz in the end. Now let's begin. For each and rows functions. In Groovy, the each method can be used as a for each loop. For example, the .each function works in the same way as a for each loop would. Also, the for loop can be used on collections. For example, we have a list and then we use the for loop and say for each items in the list you print the item. So this works on collections. Then we come to the rows functions. The rows function would select the rows from the query that is stated inside its brackets. Here the rows is used with the named parameter, but the parameter name supplied in a map. The rows are returned from the rows function and therefore they should be handled by the caller. Now we will discuss the select queries and conditions in detail. The select statement is used to retrieve records from one or more tables in your SQL database. For example, how to use a select statement. We have an example that says select steric from suppliers where city is equals to New York, order by city descending. Now in this example we have used steric to signify that we wish to view all the fields from the suppliers table where the supplier resides in New York. Now we want the results set to be sorted by city in the descending order. So we write order by city descending. This is a typical example of a select statement. Now let's discuss the select conditions in detail. The first condition is the AND condition. This is used to test for two or more conditions in a select, insert, update, or delete statement. For example, select steric from suppliers where city is New York and ranking is greater than 5. So here we are selecting, we have two conditions which are called city, and city has to be New York and the ranking has to be greater than 5. So if both the conditions are going to meet, only then will this select statement will return rows, otherwise it will not. Then we have an AND OR condition. The AND and OR condition can be combined to test for multiple conditions in a select, insert, update, or delete statement. For example, select steric from suppliers where bracket city is equals to New York and name is IBM, bracket closed, or brackets the ranking is greater and equal to 10. Now when combining these conditions, it is important to use brackets so that the database knows what order to evaluate each condition in. This is similar when you are learning the order of operations in a maths class. This is very similar to that. Then next is the between condition. This is used to retrieve values within a range in a select, insert, update, or delete statement. The syntax is select steric from suppliers where supplier ID is between 5000 and 5010. So this example would return all the rows where the supplier ID is between 5000 and 5010 inclusive, both. Then we come to the exists condition. This is used in combination with a subquery and is considered to be met if the subquery returns at least one row. Again, it can be used in the select, insert, update, or delete statement. For example, select steric from suppliers where exists, bracket, we have the subquery. Select steric from orders where suppliers.supplier ID equals to orders.supplier ID. So this example will return all the records from the supplier table where there is at least one record in the orders table with the same supplier ID, with the matching supplier ID. The next condition is the in condition. This is used to help reduce the need for multiple OR conditions in a select, insert, update, or delete statement. For example, select steric from suppliers where supplier name in bracket IBM, Hewlett Packard, Microsoft. So this would return all the rows where the supplier name is either IBM, Hewlett Packard, or Microsoft. Because the steric is used in the select, all the fields from the supplier table would appear in the result set. The next condition is the is not null condition. This is used to test for a not null value in the select, insert, update, or delete statement. For example, select steric from customers where customer name is not null. So this will return all the rows from the customers table where the customer name does not contain a null value. Then we have the is null condition. This is used to test for a null value in a select, insert, update, or delete statement. For example, select steric from suppliers where supplier name is null. So this will return all the rows, all the records from the suppliers table where the supplier name contains a null value. Then we have the like condition. This allows you to use wildcards to perform matching, pattern matching. The like condition is used in the where clause of a select, insert, update, or delete statement. For example, select supplier name from suppliers where the supplier name like U %. So this can be used to find all the suppliers name whose name begins with HEW. Then we have the not condition. This is used to negate a condition in a select, insert, update, or delete statement. For example, select steric from suppliers where supplier name not in IBM, Hewlett Packard, Microsoft. This is right opposite of the previous condition. Now this example would return all the rows from the supplier name where the supplier name is neither IBM, Hewlett Packard, or Microsoft. Sometimes it is more efficient to list the values that you do not want as opposed to the values that you do want. This can be a requirement sometimes. Then we come to the OR condition. It's used to test multiple conditions where the records are returned when any one of the conditions are met. For example, select steric from suppliers where city equals to New York or the available products are greater than equal to 250. So this would return all the suppliers that reside in either New York or have available products greater than or equal to 250. Groovy row result class. Now we will discuss this class in detail. This class is primarily used by methods of Groovy's SQL class to return result set data in map form, which allows access to the result of a SQL query by the name of the column or by the column number, which is a very useful thing. Now this is the definition of the class. It's a public class Groovy row result. It extends the Groovy object support class and it implements map. Now we'll discuss the various methods of this class. The first one is contains key. This checks if the result contains the given key or not, ignoring the case. The second is get, and it takes a property as an input. It finds the property value for the given name. Again, it does not bother about the case. Then we have the get add function. This retrieves the value of the property by its index, the int index, which is its argument. Then we have the get property method. This retrieves the value of the property by its case insensitive name. String property is the name that it takes as an input. Then we have the put method. This associates the specified value with the specified property name in this result. Then we have the put all. This copies all of the mappings from the specified map to the result. Then we have the size, which returns the size. We have a toString, which converts anything into a string, any data type into a string. Then we have the values, which sets the values. And then we have the isEmpty method, which checks if a particular string, a map, or any data type is empty or not. Now, if you want to know how many rows a SQL query return, then what should be the method to do that? We have a size method, as mentioned in the previous slide, which gives the count of the records returned. Now, how do we use this? For example, we have a data variable which contains all the rows returned from a query. We simply use data.size. We use the size method to get the number of rows returned in that query. So this is pretty straightforward. Now, how do we put the SQL query result into a list? This is also pretty straightforward, as you can see in the code. Simply put, in this code, we are trying to put the results from one MySQL query into a list. We keep adding the result of the query into a list by using the each row method. Now let's move towards the update and insert SQL queries. Now Groovy SQL is just as solid when it comes to more complex data manipulation queries such as insert, update, or delete queries. We have an example of both the queries. The first one is an insert query and the second one is an update query. You see that a simple insert in this code, which uses variable substitution again with the dollar and the curly brackets syntax. This code simply inserts a new row into the word table. Then we have the update query, which updates the table word, and it takes a list of values that will be matched to the corresponding question mark elements in the query. That means we have a list of values naming new, spelling, and NID, and they will be matched and updated with the fields which have a question mark in front of them. Parameterized execute and execute update. The first block of code uses the execute, and the second block of code uses the execute update command. Now Groovy SQL object provides the execute and execute update methods, which are reminiscent of the normal JDBC statement class, which also has an execute and execute update method. So in SQL.execute, we simply execute an insert statement, and the syntax of the insert statement is very similar to what we've done previously. And in the execute update, simply we are using an update command, which updates the values in a particular table. Now execute and execute update using a map. How is that different from the regular execute and execute updates? Actually, as long as your map keys have the same name as your object properties, so you can use the execute update without specifying the individual property names with a closure function, like done in the following code. Like the map has the same names like ID, name, URL, so it has the same key names as that in the table, so you can use it directly. Map.id, map.name, map.url. Similarly, in the execute update command, we are using the map name data as it is to update the field names f and data. Now changing a database dataset. Groovy SQL supports the notion of dataset types, which are basically object representations of database tables. With a dataset, you can iterate over rows and add new rows. So indeed, using datasets is a very convenient way of representing a collection of data common to a table. So in this code, we have basically created a dataset from the word table. We have a word table, and we use that word table, and we have created a data set, SQL.dataset, and then words.add. Using this command, we are adding a row to that data set, just like we added to a table. So basically, it becomes a convenient way of adding or deleting rows or manipulating rows when we convert the database, we change the database into a data set. Now it's time for a quiz. Question 1. Which method gives the number of rows a SQL query returned? A. Count, B. Size, C. Row count, D. Get rows. Question number 2. Write a SQL query to insert the name and number of a person into a table person. The answer to question number 1 is size, B part, and the answer to question number 2 is insert into bracket name, comma number, and then you enter the values using the dollar and the curly bracket sign. Question number 3. Which SQL condition used in combination with a subquery and is considered to be met if the subquery returns at least one row? A. Between, B. In, C. Exists, and D. Is not null. Question number 4. The Groovy row result class is used by methods of Groovy SQL class to return result set data in dash form. A. Array list, B. Hash table, C. Map, D. Linked list. The answer to question number 3 is C. Exists, and the answer to question number 4 is map. This marks the end of the quiz, and it's also the end of lecture 16. Thank you.